Hello everyone and welcome back to our videos. Today we will talk about the fluid mechanics and we will illustrate the three laws of fluids. The first one talk about the Archimedes law. The second one talk about the Pascal law. And the third one talk about the Benoulli Principle. A fluid is any substance that flows or conforms to the outline of a container. Both liquid and gases are fluids that follow many of the same rules. However, for all practical purposes, liquids are considered incompressible while gases are compressible. How that's come? For example, the air that supports an aircraft in flight and the liquid that flows in hydraulic systems both transmit force through fluid mechanics. Fluid pressure. We will talk about the pressure of the liquids. The pressure exerted by a column of liquid is determined by the height of the column and is not affected by the volume of the liquid. Buoyancy. How we can understand the meaning of buoyancy? We can understand that by the Archimedes Principle. The Archimedes Principle states that when an object is submerged in a liquid, the object displaces a volume of liquid equal to its volume and is supported by a force equal to the weight of the liquid displaced. How that's come? I will show you a figure and we will explain the Archimedes Principle in detail. We can take a simple example to understand the Archimedes Principle. We will take a 5 kilogram solid object and suspend it by spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is, and we keep a small container under the opening. Now slowly lower the solid object into the water and you will see that the reading will be a lower number as compared to the previous case. Why is that? It's because of buoyant force acting on the object. You have also noticed that some water was displaced. Now, in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes Principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. This is the Archimedes Principle. Pascals Law. Pascal's law explains that when pressure is applied to a confined liquid, the liquid exerts an equal pressure at right angles to the container that encloses it. So, as we applied a pressure to a liquid on a confined container, the liquid will produce or will give us a pressure. That pressure is equal to the right angle of the container and will transmit equal pressure to all the container, as we see here in this figure. This 1 psi and here in the end of the container 1 psi. For more emphasis, we will take another example. Here we have two pistons that transmit pressure. The first piston will apply a force that have 1 pound, and the area of it has 1 square inch, and the pressure is 1 psi. When it transmitted to the second cylinder and piston, we say here we have the area of the piston or and cylinder is 10 square inch, while the force is applied is 10 pounds. But we will say the pressure is the same. We will take the formulas that used for calculate the pressure and make you more sure for understand that the pressure it will be the same in all container. This our formula. When you want to find the pressure, you have to divide the force by the area, and if you want to find our area, you have to divide the force by the pressure, and if you want to find the force that applied, you have to multiply the pressure by the area. Here we will use the first formula to find our pressure, and when you use it on our example, you find that the pressure it will give us 1 psi in both cylinders and in both forces. The last thing we will talk about today, Benoulli Principle. The Swiss mathematician and physicist Daniel Bernoulli developed a principle that explains the relationship between potential and kinetic energy in a fluid. A venturi tube is a special shaped. This our venturi tube that explains the relationship of Bernoulli principle. The venturi tube is a specially shaped tube that is narrower in the middle than at the ends. As fluid enters the tube, it's traveling at a known velocity and pressure. When the fluid enters the restriction, it must speed up or increase its kinetic energy. However, when the kinetic energy increases, the potential energy will decreases. And this venturi tube explains what we talked about before. Here, when the velocity enters in this restricted area, the velocity will increases and the pressure will decreases. Bernoulli's principle is used in a carburetor to draw gasoline from the float bowl. The fuel discharge nozzle is in the narrowest part of the venturi, and as air is drawn through the venturi, the air pressure past the nozzle decreases. Once this occurs, the atmospheric pressure in the float bowl becomes strong enough to force fuel out of the nozzle. You will understand this more and you will take it in depth when you study power plant section chapter 1, reciprocating engine. In conclusion, I'll give you some properties of fluid pressure. The forces exerted by a fluid on the walls of its container are always perpendicular. The fluid pressure is directly proportional to the depth of fluid and to its density. Any or at any particular depth, the fluid pressure is the same in all directions. Fluid pressure is independent of the shape or area of its container.